Hello and welcome to this TechBlick Masterclass on 3D printed electronics. My name is Martin Hedges. I'm the Managing Director of Neotech AMT GmbH. Now, before we get into the agenda and the content of the Masterclass, I'd just like to give you a few words by way of introduction about Neotech, which will give you context to understanding why we are presenting this Masterclass. So Neotech is a specialist machine tool manufacturer. We're based here in Nuremberg, Germany. We've been pioneering this development. We started in 2009. We built our first systems in 2010. Those were really aimed at development and R&D applications. And we've been progressing along the lines of equipment for mass production since 2012. Now, we're active in a wide variety of industries. So moving on to the agenda. So what I'd like to do in the next hour or so is take you through the following points. Firstly, we'll take a look at what 3D printed electronics is. We'll explain a little bit about what the benefits are, why you would want to use the technology. Then we'll take a look at the different processes, the systems manufacturers, and the strategies that they apply to create 3D printed electronics. Then we'll move on and take a bit of a deeper look at the applications and the markets where 3D printed electronics is used. And that's split into two sections. We've got route 1, where you're printing on existing structures. And then we've got route 2, which is really slightly different, where you actually put your electronics either inside or outside by combining 3D printed electronics with classical 3D printing. And then what I'll do is move on and talk a little bit about the active research that's ongoing, really from a sort of a German or European perspective, and then look a little bit of where we're going to be going in the future with this, and then finalize with a summary. So let's get into it. So firstly, what is 3D printed electronics and what are its benefits? 3D printed electronics is the addition of electronics functionality through printing processes, sometimes in combination with classical surface mount devices. So this is components such as chips, resistors, LEDs, whatever happen to make up the rest of the circuitry, either onto and or into structural components to create mechatronic systems. So we can see two examples here. On the left-hand side, we have the case of printing on a 3D substrate. In this case, it's an injection molded plastic component, and you can see various components mounted onto the surface and the printed electronics functionality connecting it all together. On the right-hand side, you can see the printed electronics are actually embedded inside a mechanical structure. So what we have here is a body built by classical 3D printing, in this case an SLA process. This is the yellow material, and the electronics are contained within that. So why is 3D printed electronics used? What are the benefits of doing it compared to classical electronic systems and mechatronics when the electronics are put into a final mechanical housing to make the mechatronic device? Well, there are three main aspects that need to be considered. The first one is the design flexibility. So by removing a printed circuit board and putting your electronics functionality directly onto the mechanical structures or into the mechanical structures, you end up with highly integrated products. You've got a flexibility of shape. You're not limited by the 2D nature of a printed circuit board. You've also then got the benefits, potentially, if that's of interest, of miniaturization. You're removing a big component, the PCB itself. So you can shrink everything down. And then you can also add new functionality. So effectively, you're taking a dumb piece of structural material and adding electronics functionality to that. The second aspect really is about economics. So really the economic benefits that you might get will depend, again, case by case, application by application. But the economic benefits generally stem from things such as a reduced part count. Firstly, you don't need a PCB. You don't need to pay for that. You can also have shorter process change. You've got less assembly. One clear advantage, you don't have to put your PCB and wire that into a mechanical structure because you already build it directly into the device. You've got reduced materials usage because using printing techniques, you're working in an additive way. You're not working in the very wasteful ways that classical electronics do, where you cover an entire PCB with copper, then you etch that away, you remove